Hello everyone, welcome back to this video series on clinical SAS TFL programming. In this video, we will discuss about the lesson which is related to programming the demographic and baseline characteristics table. So in this example table which we are going to create, we'll have two numeric variable summary and two categorical variable summary. So here if you see, for age and height are the two numeric variables and sex and race are the two categorical variables. For numeric variables, the data is summarized in terms of n, which is number of subjects with available data, number of subjects with missing data, mean, standard deviation, median, Q1, Q3, minimum and maximum. Whereas for categorical variables, the statistics are represented in terms of n and percentage. N represents the number of subjects with available data for that particular category or level in the categorical variable. Let us move to the SAS session and then code this table live. So I have included the data file which has the input data for this lesson, so which is L401 of table general programming. So I have included that. So similar to the previous videos, let us include two sets of basic housekeeping things. So the first one is clear log and output windows, and for that we used dm statement. So the first one, we can clear output and then we can clear log. So and then let us clear work library. So for that we can make use of proc datasets with kill option. So for that I have added an abbreviation of pd kill, so I have my code available here. And then we have included the data file. So let us now quickly examine let us run the code till this point and then see what are the datasets that are getting created for this. So here we have an ADSL dataset being created from this %include file. So let us quickly examine the contents of that dataset. Proc contents. So for that I think I already have an abbreviation. No, I don't. Proc contents data is equal to ADSL run. So let us run this piece of code and then see. So we have around 9 variables in this. The first one is we have age variable, a race variable, analysis race, analysis sex variable, FASFL, height BL, study ID, TRT01P, TRT01PN, and USUBJ ID. So we are creating this table for 4 analysis variable, out of which 2 are numeric and 2 are categorical. The first, age and height BL are the numeric variables, and a race and a sex are the categorical variables. So let us quickly examine the unique values in at least these 4 variables and also the numeric treatment variable. So we can check that using our proc free code. So on input data set of ADSL, so I want to check the unique values present in the TR treatment variable TRT01PN first, and then the two categorical variables that we are going to use. The first one is a race and the second one is a sex. So we have treatments 1, 3, and in the A race we have Asian, Black or African American, not reputed, white. And in the A6 variable there is a row with missing value, and there is a row, there is a value called female and there is a value called male. So with the values of 1, so out of the 5 rows, 1 row has missing a A6 value and 2 rows with female and 2 rows with male. So now let us move back to the code and then try to program for this table. So we have two kinds of summaries that we need to get. The first one is numeric variable summary and the second one is categorical variable summary. So let us quickly try to identify two sections for that. So let us call this as numeric variable summary, and then the second one is categorical variable summary. So before we even jump into the numeric variable summary or categorical variable summary, we need to process our input data set to account for the total column and also get the denominators and create macro variables. So let us do that processing here. Read and process input data sets. So we had our input ADSL dataset as input. Let's subset the subjects who are part of full analysis set because the table is being generated and full analysis set. So I am filtering the records for full analysis set is equal to Y in a dataset called ADSL, and in a new dataset called ADSL02, let's create our treatment variable. Into the treatment variable, I'll use in the in order to account for the subjects under initial treatment which they are randomized to, we have to assign the value of TRT01PN to treatment variable and then output that record. And in order to account the same subject under total column, we need to replicate the row, but we need to use a different value in the treatment variable. So here in this case, we are using TRT treatment is equal to 4. So now we have our input dataset processed to have the subject counted under total column. So now let us try to fetch the denominators and create macro variables. Get treatment totals, which is nothing but our denominators, and create macro variables. So let us do that. So as always, let us try to create our dummy data set first. Input, let us call the dummy treatment totals dataset as dummy underscore TRT totals, and let's use a do loop with do treatment is equal to 1 comma 2 comma 3 comma 4 output end. So we'll get 4 rows, 1 row per each treatment which is possible or which needs to be created for this table. And in the next section we need to get the actual number of subjects in each treatment. For that we can make use of our proc freak and then specify treatment on the table statement. Let us also specify the input dataset ADSL02 and let us call this dataset as TRT totals 01, and in this dataset we need to rename the count variable as TRT total. So, and as we do not need the percent variable in this dataset, let us drop that here. And then we can remove this empty where statement. And then let us run the code till this step and see if it is working fine so far. So it looks it is working fine. So let us go and open our TRT total 0, 1, yeah, 1, 3 and 4. So there were no subjects under treatment 2. So we need to merge this dataset with dummy dataset to have that second treatment created with a row of 0. So let us also use no print option here on the proc freak as we do not need to see the output of this denominators in the output window. So now what we need to do next is merge our dummy treatment totals and actual treatment totals by treatment. So treatment totals and dummy treatment totals. So let us call the output data set as just TRT totals without the 0, 1. So it has to be based on by treatment. So if A and not B, if a subject or if a treatment is present only in the dummy treatment but not in the actual treatment, so we need to assign the TRT total as 0. So let us assign that, and then we need to create macro variables. So let us create macro variables for the treatment totals using our calls input x. As I do not need an output dataset when creating the macro variables, I am just using underscore null underscore so that no dataset is created. I'm making use of calls input x. So there are two arguments for calls input x. The first argument will take the names of the macro variables, and the second argument will take the name of the variable which contains the values for those macro variables. For the macro variables, I want to use the prefix of trt and use the value from tr treatment variable to concatenate it to trt. And then, so I'll have, if I have four treatments, so I'll have trt 1, 2, 3 and 4 created, and the value from trt total variable will get assigned to that individual row. So now we have our macro variables also created. Let us run this till this point of time and then see if everything is working fine. So let us open TRT totals and see if we have that TRT total 0 assigned for second treatment. So we do have that. Now our processing for numeric variable summary begins. So in order for all the possible treatments to be created, we use the concept of complete types in proc summary. For that we need a treatment, uh, a format containing all the possible treatment levels to be created. So we are making use of proc format to create that. So we are expecting four treatments in this. So let me, so we are creating a format which has all four levels. So, and the next thing is that we need to get the two analysis variables into a single variable and use a grouping variable to identify which value is present in what variable. So for that, let us create a data set called ADSL03 underscore numeric and using ADSL02 as input. So in this, so we now have group is equal to 1. So when I'm giving this group, I'll go back and refer my table. So here in this table, so I am assuming that, so there are four sections. So I'll call this as group 1, group 2, group 3 and group 4, because we need to present these sections in the same order. So it is better if we create a numeric variable which has uh, 1 for age, 2 for sex, 3 for height and 4 for race. So let us assign it. So as we need to present age on the top, so I'll assign a value of 1 for age group. As height is on the third section in this report, I'll assign a value of 3 for, I am creating rows for height variable. So let me go back to the code and then here, so let us create two variables. So let us create this variable called group label and assign a length of 200 to it. So for group label, when for age is as per the layout. So let me go back to the shell. So it is age underscore age years. So let me paste that into the code. And then, so when I want to create a common variable for both age and height so that I can get the results using a single proc summary step. So result is equal to, so this is the first group, so I need to use the value from age variable in the result variable. Now I will just replicate these three and then paste it here. As height is the third group, I will give a value of 3 in group variable. So let us go back to the shell and fetch the height label that needs to be used. So here it is 3. The variable in which height is present is height BL. So as we have, so I have created a data set which will have one row per uh, analysis value in the variable result from age and the second row with the value in result variable from height BL. So let us try to run the code till this point in time and then see if it is working fine. So there is a typo. Height BL is misspelled as height HEIGBL. So the T is missing. So SAS has thrown us a warning saying that, note saying that height B, it cannot find height BL variable without a T. So let us fix that and then try to run it again and then see if everything is working fine. So we do have it. So we had 10 observations in the input data set. So if we are outputting it twice, once for age and once for height BL, so we are expecting 20 observations. So that is what we have. So let us open ADSL03 numeric and then see what is happening. So here each row is now replicated twice, once with group is equal to 1 and the second time with group is equal to 3. On the record where group is equal to 1, in the result variable we use the value from age, so which has 23, and on the record with group is equal to 3 we use the value from height BL into result variable, so we have height BL is equal to 3. So when we now do by group processing at group and group label level, we'll get a separate summary for age and height within a single proc summary. So now we have created this data set. Let us use, let us get the summary statistics using proc summary. So let us make use of the summary abbreviation, which is PSUM in my case. So as we no longer need these options, so let me remove them. So the input data set here in this case is ADSL03 numeric. As we need to do by group processing, I'll sort the data set based on ADSL03 numeric based on group and group label. So, and then here I'll use this by statement and then specify group and group label. So ADSL03 numeric, and then the class statement we need to specify treatment. So here we want to have a column or statistic being created for all the 4 treatments. So for that purpose what we are trying to do here is make use of preload FMT. So if we are using preload FMT, I also need to, whenever we use class statement, we need to specify NWay if we are interested in getting the overall summary. A summary at each individual class variable levels at the nth level interaction. And then we need to specify complete types so that all the levels present in this format gets preloaded and we'll get a summary for each possible treatment even if that level is absent in data. So it uses the values from format instead of relying only on the data present in the input data set. So the analysis variable here is our result variable, which has the information for both age and height, but they are distinguished by the variable values in group and group level. So let us call this outputs dataset as stat01. So here we are interested in, as per the table layout, so we need n, missing, mean, st, median, q1, q3, min, max. So we need min and max statistics. So let us go and add all these statistics into our code. So we had n, miss, mean, standard deviation, minimum, q1, median, q3, max, and we don't need range. So let us remove that. So let us count this once again. 1, 2, 3, 4, 5, 6, 7, 8, 9 statistics are required. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have all 9 statistics present here and we are using auto name option so that we get the names of the statistics automatically without giving it here after the keyword of the statistic. So let us run the code till here and then see how the output dataset looks like. So okay, it said there is a warning which says the format for variable treatment cannot be preloaded. So we said we are going to use a format for treatment variable on the class statement, but we have not applied a format for treatment variable. So let us apply that format for treatment variable using format statement. So we have also named the format as treatment, so we'll use that. Let us run this code and now see. Yep, the code ran fine. Now let us examine the stat01 dataset. So we have given the analysis variable as result. So as we have used autoname option, SAS automatically names the variables for the statistics which we have requested with the prefix of the name of the variable which we have used and an additional underscore, which is result underscore n, result underscore n miss, and so on. So we have result underscore n, result underscore n miss, mean, std dev, min, q1, q3, and so on. So these are all numeric versions, and we also need the concatenated versions of this statistics into this one. So let us create a data step and create the character versions of the statistics and also concatenate them as per the table presentation requirement. So we let us create n, and so we may not need an nmis. So mean, standard deviation, minimum, q1. So I'm creating all these variables to store the character version of the statistics. So I am naming all the variables required. So along with these individual statistics, we also need to concatenate n and miss. We need to concatenate mean, standard deviation. We need to concatenate q1, q3. We need to concatenate min, max. So I'll give a length of 30 for all these variables. So now let us try to create the character versions of variables. We'll begin with mean first. So result underscore mean not is equal to missing. Then I am creating a variable called mean by applying a format of 5.1 as I want to present one decimal for the statistic of both age and height. So for main variable. So I have done that. So let us copy this and paste it for other statistics as well. So here for standard deviation it is std dev not is equal to missing. Then so what was the name of the variable that we have used? It is std. So here we need to give std dev with a value of 6.2. So as we need to present two decimals for standard deviation, and then we'll do the same processing for median. So let us copy this. Let us create the new variable as median and use the median variable as input. So and then let us do the processing for q1. Let us name the character variable as q1 using the result underscore q1 variable. So and for similarly for q3. So let us name the character variable to be created as q3 using the variable result underscore q3. So we also need to replicate this for min and max. So let us do that. So let us create min. So for min, so I only want to present the integers, so I will use a format of 3 dot. So similarly for max, so here also we need to change. So result underscore max and change the format for the input function or the put function to 3 dot. Let us try to quickly run this code and see if there are any syntax level issues. So we have created some variables, but we have not created the character versions of those. So we have some uninitialized nodes, but we will be creating them in a while. So let us open stat02 and then see if the character versions of the variables are getting created. Yes, they are getting created. So now let us try to create the concatenated statistics. So one additional change that we'll make here is else if standard deviation is missing. So we will put standard deviation is equal to, we'll put an opening parenthesis, standard deviation as hyphen, and then close it. And here also we'll try to put the standard deviation within parenthesis. Because we have to present the standard deviation within the parenthesis here. So I am adding that parenthesis as part of creation of the standard deviation variable character version itself. So now let us come back and then create the concatenated statistics. So first we'll begin with n and miss. So here for n and miss, so we can directly use put function with a 3 dot, and then as we need an opening parenthesis, so what we can do here is add that opening parenthesis, use the concatenation operator again and put off and miss. So here the variable that we have created is result underscore n, and same thing has to be used for n miss with a 3 dot, and then after that we need to add a closing parenthesis. So we are adding that, and then let us create the concatenated statistics for other things. So all the concatenated statistics will have a meaning only if result underscore n is not equal to 0, then do. So let us do that concatenation. So we want to create mean SD. So mean SD is equal to, so let us use trim of mean, then concatenate trim of STD. So, and then we need to concatenate Q1 and Q3. So let us create the concatenated variable Q1, Q3 by using apply trim on Q1, and then we need to add a comma in between Q1 and Q3 followed by again Q3. So let's also create the concatenated statistic of min max. So let us apply the same logic for which we have used for Q1, Q3. So use a comma in between and then trim of max. So we have created the NNMA statistic mean SD Q1 Q3 min max for median. So it is presented as a standalone row. So we have already created that character version, so we can make use of that variable. So let us run this entire piece of code and see. So we have a syntax error. So we have added an additional comma after this comma in between. So let us remove that and then try running it again. So now earlier there were uninitialized variables, uninitialized nodes for the variables which we have not created. So now as we have created all the concatenated variables which we have specified on the length statement, the uninitialized nodes are now gone. So let us open stat02 and see how this looks like. So we have all the variables created. So for mean, there looks like there is some issue. Let us see mean st trim of mean. If result underscore mean not is equal to missing, then mean is equal to put of result mean. So why are we not getting? This is standard deviation, where is mean st? So for mean st, this is getting created properly, so not an issue. So let us now create a new data set and then keep only the required variables. So let us name this data set as stat03 and use a keep statement. So we need group label. So we need n and miss, and then we need mean st, and then we need median q1 q3, and we need min max. So the individual variables which identifies the group and the concatenated or the individual statistics that have to be presented are only kept. So let us run this entire piece of code and then check again the stat03 dataset. So we have n and miss, mean st, median q1 q3, and min and max. So we forgot we also need to keep the treatment variable. So we will have, so we now have treatment variable as well. So there are two analysis variables and four treatments. So there is one row for each treatment. So but here in this, so we have the statistics available as rows, but as per the table presentation requirement, we need these as uh, we have these as columns, but we need these as rows. So for that we need to make use of transpose. So let us apply that transpose. So in order to apply the transpose, we also need to make sure that the records are sorted based on the same by variable. So let us use stats03 on this sort step. Sort the records based on group and group label and treatment. So we can carry forward the same by variables onto the transpose. The variables that we want to transpose are n and miss, mean, SD, median, q1, q3, min, max. So, and there is no need for ID statement here as we are transposing variables to rows. So, and we also don't need this where statement. The input data set for this transpose is our stat03. Let us call the output data set from proc transpose as stat04. So let us run this entire piece of code and then see if it is working fine. So the log seems to be clean. Let us now open stat04 and see if the statistics columns are now appearing as rows. Yes, so we have all the statistic columns are now appearing as rows. So now let us create a variable like which in the way the table has to be displayed. So for example, for n and missing, so we need this small n and the missing text has to be within the parentheses. For main and SD, there is a particular display label. So we'll create a display label variable and also an order variable for these individual statistics so that those can be used in sorting purposes to have the report ordered in the same way. So in the next step, we will create those variables. So let us create a new data step and use the stat04 as input and then create a new data set named stat05. In this data set, let's create a variable called statistic to hold the text that has to be displayed for each statistic. So here we will be making use of the underscore name underscore variable. So let us try to convert those into all uppercase and then we'll use this underscore name underscore variable. So if it is n and miss, so we want to have that internal order as 1 and then statistic is equal to, so here the text was n and within the parenthesis we had to present this one. So let us end this one. So let us copy this and then replicate it for other statistics. So the second one is mean SD. So for main SD, the order is 2. Let us increment the order first. So for main SD, the display text was main and within the parentheses SD was there. So and then the next statistic was median. So for median, the text was median. Let us go back and cross check main SD, median, Q1, Q3 and min max. So now the next is Q1, Q3, Q1, Q3. So the display label was Q1, comma, space, Q3. So I think we need to add a space after the value as well in the Q1, Q3 concatenated statistic, similar to that we have in label. And then we have this min max concatenated variable. For that, the display label is min, comma, max. So let us run this code and then see if it is working fine. So we have all the code ran fine without any log issues. So let us open stat05 and see how that looks like. So we have added the statistic column with the same display text that has to be used in the report. And then we have created this internal order variable for the rows to be ordered properly. So now, so here we have the treatments available as rows, but as per the table presentation requirement, we need to have these as columns. So let us do that transformation again using a next proc transpose step. Let us sort the data set again based on stats05 by, so we need to have group appearing as column, so we need to use it on by. So and also group label will also needs to be a variable in the proc transpose data interorder and statistic here. So let us remove this empty where. So ptrans. So here we'll have to keep all these variables as variables, but transpose the column 1 which had the statistic values as into the table is needs to be restructured with the value present in column variable being transposed and with the ID values being the values from treatment variable. So data is equal to stats05. The output data set, let's call it as stats06, and then let us use prefix is equal to option and then use the value txt on that. So we are transposing the values from col1 variable with the treatment variable values on ID statement, and then let us run this piece of code and see how the table looks like. So TRT1, TRT2, 3 and 4, now all these columns are transposed correctly. Now we have completed the processing for numeric variables with the statistics for all the treatments obtained, and those statistics for each treatment are now arranged into columns. So the next thing that we need to do is the processing for categorical variables. So let us do that. So let us create a final data set called final underscore numeric and then use stats06 as input and keep only the required variable. So we need group label, int order, statistic and TRT1, TRT2, TRT3 and TRT4. So we only need these columns, so we will keep only those columns in the final numeric data set. So now we need to do the processing for categorical variables and then append this final numeric to that final data set of categorical variables before we jump into reporting portion. So for categorical variables, let us try to create that pre-processed data set. The ADSL02 was the input data set which we had the treatment rows replicated. So using that data set, let us create a data set called ADSL03 underscore categorical. So here we need to create a single variable called statistic and then assign the values from sex variable and arrays variable for the processing to be in a single proc freq to obtain the counts. So let us go back to the shell and then see the for sex it is 2 and then for race the group number is 4. So the sex is the second section in the report. So we'll use a value of 2 for this variable and 4 for race variable. So group is equal to 2. So before that, let us assign group label a length of 200, similar to what we have assigned here in the when we were creating the numeric variable summary. Here, let's call the group label. So let's go back to the report and then use this value for group label. So and then so we need to also create the variable called statistic. So statistic is equal to when we are creating it for group 2, the values from ASX variable will become the values for statistic. And then for group is equal to 4, group label is equal to race comma n and within the parenthesis the percentage. And then here the statistic values will come from arrays variable. So we now have created a separate row for uh, sex variable to be present in statistic variable and a separate row containing the value from arrays variable into the statistic variable, and those two rows will be distinguished based on the value of group and group label. Let us run this piece of code and then see how that looks like. So ADSL03 underscore categorical. So we have replicated one row present in the input data set to two rows. In the first row, we have used the value for in the statistic variable, we have used the value from A6 variable. So, and we have identified that as with the value of 2 in group variable. And the replicated row on the where we have used a value of 4 in group is group variable, we have fetched the value into statistic variable from arrays. So in the statistic variable, now we will be able to differentiate whether the value is from arrays or sex based on the values in group and group label rows. Now after that, what we need to do is fetch the counts for actual counts. So let us create. So the ADSL03 underscore dataset underscore categorical dataset becomes input. Here the counts needs to be fetched at group, group label and statistic level. So let us call this dataset as counts 01, and as we do not need percent variable from this, so let us drop the percent variable. So let us run this piece of code and let's also make use of no print option on this proc freq. So let us run this code and then see how the output dataset looks like. So we have called it as count01. So let us open that dataset. One additional change that we had to do was on the whenever A6 is missing, we have to, if A6 not is equal to missing, then statistic has that value, else statistic should have a text of missing. So let us incorporate that as well. So here also we need to incorporate the same change. If arrays not is equal to missing, then statistic is equal to arrays, else we'll assign the text missing to the statistic variable. So let us rerun these two steps and then see how the code. So I have to close this. So let us open count01 now and see. So now we have obtained the counts for both sex and race for the data available in the for the in the input data. So there are some values which are missing in some of the treatments. So are the all the treatments. So for that we need to create dummy values for each of these levels which are present in the shell and then merge it with the actual counts. So let us now create that dummy data set p data. So we in this we are creating, let's call this data set as dummy01. So we need to create length for group label needs to be assigned and statistic needs to be assigned, and we used a value of 200 earlier, so we'll have to use the same length here. And then so here let's create that rows. Group is equal to 2 and group label is equal to, so the first one we have used a group label of sex percentage. So let us copy that. So here under group is equal to 2 as per the TFL layout. So we had male, female and missing. So with the order of presentation in the same way, male, female and missing. So let us use the same variable name which we have used to sort the descriptive statistics for numeric variable, which was int_ord. So I'm using the same name. So int_ord is equal to 1. The first level that has to be presented is for male. So I'll use output here. So let us copy this and paste it for other two rows. So the second one is female and the third one is for missing row. So now let us create row values for group is equal to 4, which is race. So here I'll just do one thing. I'll just copy one of the statements and replicate it here. So or else I can copy these three. So let's go back to the shell and see what are the possible values. So the first one is Asian. So I'm copying the second value. So let us use this value here. The first one was Asian. So I pasted it. And the third one was white. So I'll use that. And then the fourth one is not reported and fifth one is missing. So let us go back to the code and replicate these two rows. And let us create the internal order 4 and internal order 5th variable for this one. This was not reported and the last one was missing. So let us try to execute this code and see if we are getting all 8 rows. So we have no log issues, which means that the code is run successfully. So we have all 8 levels of both sex and race variables are displayed. So now what we need to do is create a row for each of these individual level for each treatment. So for that what we can do is we can make use of a data step, use the dummy01 as input and then create dummy02 data set. Here we need to replicate the rows for each treatment. So I'll make use of a dummy do loop. So, and then I'll use output within the loop. So let us run this code and see what's happening. So I have dummy02 dataset created, and then so in this I have now one row per each treatment and each level of the categorical variables. So now let's do this merging of actual versus dummy rows. So let us sort the dataset and then merge the dataset. So for sorting, what we need to do is sort the values based on group label, INTORD, and statistic. I think INTORD is not present in the actual data, so we cannot use that. So let us sort our count 01, which has the actual counts also based on the same variables. Now let us merge both these data sets based on group label and statistic. So count 01 will use as the second data set on the merge statement, and then dummy02 will use as the first data set. And let's name the output data set coming out of this merging of dummy and actual counts as count 02. And if a record is present only in dummy data set but not in the actual data on those rows, we want to set the count to 0. So we have done that. So let us run till this point of time and then see how our count 02 looks like. So now we have mm, so something seems to be not right. The count 02 dataset is getting counts on all rows. We were expecting some zeros, so something is not right. Let's go and try to figure out what's wrong. So we need to merge both the dummy dataset and actual dataset based on group, statistic, and treatment as well. So let us add treatment as well to the by group and also to the merge statement. Now let us try to run the entire piece of code and then see if it is. It says treatment is not available on count 01. So did we not get the counts at treatment level in our actual data set? Yes, so this is missing here as well. So we need to obtain the counts at each treatment level. So I have included that now. So let us run the code once again and then see at least if this works fine now. So yeah, let us open count 02 and then see. Yes, there were some rows which were only present in dummy but not in actual. So for example, there was no female subject in treatment 2. So we were getting only that row in the dummy dataset. So we have assigned a value of 0 here in the count 02 dataset. And the next step that we need to do is calculate percentages. So CMNT1. So let us say calculate percentages. So for that we need to fetch treatment totals into our count 02 dataset. For that we need to sort our counts 02 dataset based on treatment, and then we need to replicate the same sort for treatment totals, and then merge the treatment totals dataset to counts 02 dataset, and let us call the output dataset as count 03, and we need to specify treatment on the by statement. So we can just specify the if the row is coming from count 0 to only keep those rows. So let us run this point of code. So we have count 03 created. Let us see if we have treatment total coming in as a variable. So we have treatment total available alongside the count variable. Now we can calculate percentages. So let us calculate percentages in a new data set, and let's use count 03 as input and then call the output data set as count 05. So let us create the counts percentage variable with the name CP and then assign a length of 30 to it. So here if count not is equal to 0, then CP is equal to put of count and then followed by percentage. We need to put it in parentheses. So let us create that opening parenthesis and then calculate percentage and convert it into character format using put function with a format of 5.1. So now else when count is equal to 0, all we need to do is we can just put the only the count in the CP variable. So let us run this piece of code and see if it is working fine. So let us open count 04 and then see if CP variable is created properly. Yes. So now we will do the transpose. So far in count 04, the treatments are appearing as rows. So we need to now make a column for each treatment with the values from CP variable distributed. So now let us do that processing by sorting count 04 and then transposing it. So for this, what we need to do is we need to keep group as a variable. So we need to specify on the by statement. So group label, int order, statistic. So all of these variables needs to remain as variables when we are transposing. So we are sorting the data set based on those variables, and then we are specifying that CP has to be transposed, and then we need to name the newly created columns with the values from treatment variable. And let's call the output data set as counts05, and then let's use a prefix of trt here, and then we can remove this empty where statement. So let us run this sort step and transpose step and then see if it is working fine. So now it seems to be working fine. Let's open count05 dataset and then see if this looks okay. So we have the dataset created. Now we have ensured that the let's create a final dataset for categorical variables. So let's call that dataset as final underscore categorical and keep only the required variables. Keep group label int order statistic trt1 trt2 trt3 and trt4. So what we have done here is that we have ensured that the final variables which get created out of the numeric processing and the categorical variable processing have the same name, so that when we append these two summaries, so we do not need to change anything or rename the variables at the time of appending. So we need to keep this in mind and make sure that the variables which are being used for this column for both categorical and continuous variables have the same name, same length, and similarly for statistic column also the values that have to be displayed in the for categorical variable are to be kept in the same named variable is as same as for the numeric descriptive statistic labels. So that way, after appending, you will have to make minimal changes. So now let us combine the descriptive statistics for numeric variables and summary for categorical variables. Combine numeric and categorical variable summaries. So let us call the dataset as final, and then we want to use the final underscore numeric dataset and final underscore categorical. So let us run this entire piece of code and see if it is working fine. So let us open final. So we now have summary for numeric variables, this group 1 and 3, and then group 2 and 4 for categorical variables. So now all we need to do is just resort this dataset based on group and internal order so that 1, 2, 3 and 4 appear as per the presentation requirement. So let us sort final dataset based on group, group label and internal order and statistic. So let us run this entire piece of code again and then see the final dataset. So if you see now, in the final dataset, all the group 1 statistics are appearing together, followed by group 2, 3 and 4. Now all we need to do now is to write the report section to have this table completed. So let us call this section as generate report. For that, let us write the proc report code. Input data is final dataset. So let us use the option no windows, headline, head skip, and let us use a line size of 150 and then page size of 40, and then use the column statement to specify the ordering variables and also the text variables that have to be displayed. So group, we need it for sorting the groups, and group label is needed. We need to display it as the first column in the report, and then internal order variable is required for sorting the rows for each individual statistics within the numeric variables and the individual levels of the categorical variables. And then statistic column, we have the display labels for numeric variable descriptive statistics and the levels of categorical variables. And then we have our treatment variables. So we need these columns. So let us write the define statements for these individual columns. So define group. So we do not want, we only want to use it for ordering but not printing. So we'll use no print option. Same is the case for int ord, so order no print. And then let's define the group label column. So the width, do we have any header? So we do not have any header for group label. So we can ignore or we can add some description for this one. So let us go back to the report and let's call this as variable. And then, so we want to print only the first occurrence of the group label. So we will use order option on this group label. And then, so let us use a width of 20 for this and also apply flow. So define, and the next column that is to be displayed is statistic. So for which the label is statistics. So let us apply that. And then the width can be around 30, and then let's also add flow option. So define trt1. So the label for this is dose level 1, and we also need to display the number of subjects in this treatment. So let us use that macro variable here and then display the in the header. So let us use a width of 20 for this column, and let us copy this and replicate it 3 more times, and then change it for treatment 2, 3, 4. So let us make this dose level 2, dose level 3, and then final column, let's make it as total. So let us give some space to, so 2, the third column macro variable name will be 3, fourth column macro variable name will be 4. And after that, we need to give a blank line after each group. So for that, what we can do is make use of our compute block. So compute after each group. So use a line statement and then write a blank line. So let us try to run this entire piece of code and see if it works fine. So let us also add the missing option. So in case if any of the variables which are used as group or order, if has a missing value, if we do not use the missing option, those rows get excluded from the report. So to be on the safer side, for none of the rows to be excluded, so I have added missing option on the proc report statement. So this seems to be working fine. Now we have our report generated. So we had no subjects in treatment 2, so we had to display it as 0 and all the zeros wherever applicable. And then we had one subject in dose level 1 and 3 subjects in dose level 4. So we had the total column count accordingly as 5. So we now also have a blank line written after each group, and then as we have used order on the column which is used for group label, so only the first occurrence of that value will be printed. So if we take a look at the input data set, so we would have had the group label on all the rows, but as we have used the order option, what happens in the report is, so within that group, only the first occurrence will be printed. So this is how we can program a demographics table in around 1 hour 10 minutes. So, and this entire section of code is very scalable. We can include uh, more variables in either categorical or continuous variables in this section. So if we have any requirement to add more continuous or categorical variables. So if we have to add continuous variables, so this is the section where we need to add. And if we have to add categorical variables, more categorical variables, so this is one section where you need to replicate the output statement, and then you need to create the relevant dummy rows to present all the levels. So this completes our programming for demographics table without using any macros in this. Thank you for watching and keep learning.